Hello, good morning, good afternoon to everybody. And thank you very much for joining us in this webinar about Busbar protection, differential Busbar protection. My name is Íñigo Bilbao. I'm from the CRIB sales department. And well, today's event is part of the 2025 CRIB's training plan, in which we are including online sessions like this one, in which on the 3rd and the 4th Thursday of every month, we give webinars of like this one, and also part of the paid in-person training sessions that we are doing in that we call CRIB University, both here in Bilbao and in Barcelona. You can find information about all these events in our website. I take the opportunity to comment that the next week webinar has been cancelled for reasons, several reasons, and we are going to reprogram it, which we'll inform you in the next few days. Well, the session today is going to be 30 minutes, 20 minutes in which we will make the presentation, and 10 minutes at the end that we will leave for questions and clarification. I encourage you now to go to the display button and select the full screen function, and with that you will be able to see the full screen and the better viewing experience, and send us any question through the chat. Okay, now I present you to my colleague Oscar Pereira, who will be the person who will give you the detail of this webinar.
Okay, thank you, Íñigo. Hello, everybody. First of all, as my colleague said, thank you so much for your attendance today, and I hope that you find this topic interesting for all of you. Today, I will present you our Busbar differential protection that works under an IC 61850 environment. So, in other words, I will show you how our Busbar differential has been designed to operate within the so-called the process bus. So these are mainly the four areas that I will be presenting to you today. So, which is the arrangement of functions and the concept of our Busbar differential protection, the physical description, the protection functions included, and finally, some tips related to the communications. By the way, in the picture, you can see the arrangement that we have in our laboratory, in our factory. But this is a point to explain you, or to first of all mention here, that our Busbar differential protection follows a distributed architecture, meaning that we are using a central unit and bay units for each of the circuits or of the bays going into or going out of the busbars. So, as you can see on the screen on the left side, you see how we have a central unit that we call DBF in blue letters, DBF, that is the central unit. And then after that, per each bay, we have to install a bay unit that we call IRF. So, as I told you, this is a distributed arrangement. So, all the bay units are installed as closer as possible to the CTs, to each CT in each bay, as it's shown on the picture. And more than that, an advantage as well, apart from this short distance between the CT and the bay unit, additionally, the good thing is that this bay unit intended for the Busbar differential protection may include as well the rest of the protection functions that are typical in a bay unit, for example, in a feeder or in a transformer. So if we move to the right side of the slide, I started this presentation saying that our Busbar differential protection works under 61850 using the process bus. So it's you can see the red diagrams showing how the central unit and the bay units are all of them interconnected in this same bus, exchanging certain relevant information for the for example, I am showing there on the bottom side the bay unit, IRF, and the central unit, DBF. Very quickly, I am showing how, for example, each bay unit will send the central unit relevant information for the algorithm, for the differential busbar protection, such as the status of the breakers, the status of the disconnectors, of course, the values of the current in the three phases. This is very easy to understand. On the other side, the central unit will send information to the different bay units when in case of a busbar differential trip, or in case of any blocking, or even for synchronization or whatever. So, as I told you, we have a distributed arrangement with all the modules interconnected and in a process bus according to the standard 61850. This distributed arrangement of our busbar differential protection, you should know that part of the protection functions are included or embedded into the central unit, into the DBF, but there are also other specific protection functions that are included in each of the bay units, in each of the IRF. So on the screen now, you can see the list of the protection functions included in each of the two modules involved, okay? So in the following slides, I will give you some basic clues about each of these protection functions. Very quickly, for example, in the case of the DBF, it's easy to understand that it's the place where, let's say, the differential unit is located, the differential unit 87B. But apart from that differential protection, we have another additional units also that are located there, such as an alarm unit, the supervision unit, commonly known as the check zone, inrush detector, lockout, etc. So those are certain protection functions that, due to its nature, the place to be is the central unit. However, on the other side, there are other protection functions that are directly related to each of the bay unit in particular. So in those cases, such protection functions are in each of the bay units. So in what we call in our unit called IRF. For example, the breaker failure unit. For example, the CT supervision. Clearly, the CT supervision of the breaker failure, we are talking about a single bay unit, about the same breaker and the same CT. So it seems quite logical that these protection functions are included in bay units, the dynamic zone, etc. Well, and here in this, let's say, logical diagram, we try to explain you how is the interaction between the central unit and all the bay units. So, as you can see, the bay unit in yellow in the middle of the picture will receive from the field the status of the breakers, of the isolators, even the analog measurements, the currents in the three phases. And as you can see, these green inputs, let's say, to the bay unit will be sent to the central unit. The central unit will, with the algorithms, internal algorithms, will make the calculation through the blue boxes, the phase differential, the supervision differential, and so on. So the central unit will operate the algorithms and will decide whether there is a busbar trip or not, okay? So if needed, in case of a fault, again, the central unit, as you can see in a black arrow, will send the will send the trip to the bay units involved or the bay units connected to the faulty busbar. Okay. So in any case, as we go further in this presentation, you will identify later on all of these parts of the diagram. Okay. Well, this is regarding the concept of our distributed busbar protection and how the different elements are interconnected. If we, with regards to the physical description, well, you should know that both the central unit and the bay units share the same platform. It's what we call it's our F family that is based in a modular solution that is expandable, as you can see on the screen. So while the central unit is housed in a 1/3 rack box, the bay units, it can be bigger or smaller depending on the application and your needs. So we may have bay units of 1/3 rack, half rack, or even one complete 19 inches rack. Depending on that, I am showing you there, which is the maximum number of digital inputs or outputs per bay, per each bay unit, the IRF, okay? It's as interesting as the front part of this relay is also the back part, the back side of the relays. And here you can see a detailed information about the ports that are so relevant in a kind of protection like this, where all the elements are interconnected. So, well, we have a BNC port for a standard synchronization. We have remote ports 1 or 2 are serial ports for main purposes, and so on. We have, and the important part comes here when we talk about the Ethernet ports, LAN 1, 2, 3, and 4. Well, out of those 4, the most relevant for this specific application are the LANs 3 and 4, because are the ports that we use for the IC61850 process bus. So those specific ports are intended for the communication between the central unit and the bay units. Are ports that will operate at 1 gigabit per second. The physical media will be fiber optic LC connectors. And I will show you later which is the kind of arrangement or topology between the central unit and the bay units. But important to keep in mind that these LANs 3 and 4 are specifically and exclusively used for the communication of the central unit and the bay units. Is what is called the process bus in the standard 61850. Still, of course, we have LAN 1 and 2 for IC 61850 station bus. I mean, you in the future or even now, you may have the rest of the protections in your substation, a transformer differential protection or an automatic voltage regulator or whatever. Those can as well be interconnected under 61850, but in that case, it's a separate bus that we call the station bus. So this central unit will be prepared for, and also the bay units, to operate both in a station bus and in a process bus. Well, in the case of the busbar protection, those are the two the two possible redundancies or that we can use here. One is the HSR on the left side, or the PRP, the parallel redundant protocol. So these two are the topologies that have been proven to be the only ones that are acceptable for a busbar differential protection. Why? Well, because a busbar differential protection requires a time response or an execution time of around 2 milliseconds. So any other physical or redundancy solution that is not able to secure a recovery time of around of 2 milliseconds couldn't be acceptable. So that's the reason why only HSR or PRP are the ones that are valid for this busbar differential protection. On the right side, we have a ring where all central unit and bay units are connected. This solution, if you have in one point, one problem, one cut, let's say, still the communication is warranted, right? If you have more than one point with problem, if you cut into points, so the communication is not working anymore because you have a part of your substation that is isolated from the rest. Is still something stronger than the HSR because in this case, with the use of Ethernet switches, you may have two independent networks. So in this case, even with two, let's say, problematic points with two cuts, still you have availability of your system. However, according to the experience of the different philosophies and so on of the customers, of the utilities, it's quite usual to go for the HSR protocol and redundancy. Why? Because you are not introducing a new vendor or a new device in the system. So in case of a problem, if you are following an HSR, you have the problem focus on the same vendor and on the same kind of equipments. However, if you have an arrangement involving switches and any problem happens, well, probably the solution could be something more difficult to identify. So please keep in mind that only these two are possible, HSR or PRP, being the HSR the most frequently used. Well, regarding the protection functions, as I mentioned to you at the beginning, most of them are located in the central unit, in the DBF, but still some others are located in the bay unit, in the IRF. The list is there for your future check, right? And now I think we have 4 or 5 minutes left, so very quickly, I will just show you or give you some words about any of the protection functions. But of course, we can have time at the end of this presentation for further discussions or even in the following days. Okay, but okay, just for you to show, our differential unit is the typical with 2 slopes with a sensitive current value, and it operates following the characteristic that is shown in the picture. Okay. Well, apart from the busbar from the differential unit, we have also the supervision differential unit, or commonly called as the check zone. So in this case, the thing here is that the characteristic follows the same idea. In this case, the thing is that the substation, or let's say, yes, the substation is considered as a single busbar. So it's a way to check or to double check that the busbar differential trip is correct. Okay, the alarm differential unit, this is intended to detect in case you have some CT failure or some problem in your substation. So in this case, the characteristic follows a fixed value. It's not with slopes, but this is useful to inform you that there is a problem in your substation with any CT or with a circuit breaker, sorry, with a short circuit in some of the windings, for example, of a transformer, etc. Also, we have another unit that is the external fault detector. This is a critical and very important protection function in our relay, because we have to detect when we have an external fault, mainly when under a situation of CT saturations. So to detect those risky faults that are outside of the busbar, but however are provoking the saturation of the CTs, we have this unit that uses three criteria as mentioned there on the screen. So the user can select under, of course, the activation of this unit will block always the trip of the busbar. And here what we explain is that we can decide whether you need the three criteria activated to block the trip, or only with 2 out of 3 is enough. This requires a quite explanation in detail that this is not now the moment for this, because requires a longer time for that. But in any case, this presentation will be with you and for, of course, our further support. Okay. Also, we have another, let's say, another unit or to block the differential protection in case of communication failures. As you can imagine, the communications are the key in a protection like this, with all the elements interconnected. So any communication failure, both or in the sample values exchange, or in the currents exchange between the central unit and the bay units, or a communication failure related to the goose messages that are exchanged between the central unit and the bay unit, even one or the other, will cause or will block the differential protection. Okay. Of course, when this communication failure disappears, then the busbar differential is still activated. And well, there are more units, for example, like the dynamic zone. This is to prevent malfunctions or false trips when you have a breaker open and you have a fault between the breaker that is open and the CT. So the dynamic zone prevents you from situations like that, from false trips under that conditions. And also we have another unit specific for couplers when you are using just one CT, etc. But again, well, this takes quite a long time to explain now. And finally, well, this is just to reinforce the message, which is the type of communication between the central unit and the bay unit, mainly sample values and goose messages. Also the synchronization that goes from the central unit to the bay units. And on the bottom side of the picture, you can see in detail all the goose messages that are exchanged using the process bus. And well, finally, well, here you have some, regarding communication, some values for your information, but it reinforces the message of which is the processing time less than 2 milliseconds. The synchronization, that should be a PTP synchronization, because it's the one that can support the time stamping required in the sample values exchange. And finally, also, what I mentioned at the beginning, that the process bus will be operating in a 1 gigabit per second fiber optic network. And finally, for all those wondering what about the 61850 configuration, well, I'm happy to say you that we have the good news, because we have a communication program, the ZIB Inet tool, that includes a configuration wizard. So for those that are not expert on 61850, in a very friendly way, you can get the files. The program will give you the files to configure all the central unit and the base units under 61850 just by introducing very basic information like the number of base, that if are couplers or not, and if there are disconnectors or not, etc. So with the configuration wizard, don't be afraid of using a busbar differential using the 61850 station process bus. And yeah, and that's all. Those are the presentation that I prepared for today. Sorry, because I think I consume maybe 4 or 5 minutes more than expected, but in any case, feel free to make any questions, and I will try to reply to them right now. For example, yes, how many protection zones can be covered? Yes, yes, probably those are something that I should mention at the beginning. 4 zones, okay? So our busbar protection is able to operate in substations with up to 4 busbars, even being 2 out of those 4 even could be transfer bars, if that is your case or not. But in any case, 4 busbars, so 4 protection zones, and up to 20 bays. Okay. And say another question. Rintamaki is asking, how many bay units can be connected to an HSR ring? Okay, as I mentioned just now, the maximum, I mean, that is determined by our design, that at this moment is for 20 bays and the central unit. So this is the maximum number of, let's say, of elements connected to the ring, 20 plus 1. Please feel free if anyone has any more questions. Yeah, for example, I think in the last slide, I was saying how the synchronization should be the called PTP, because that one is, as you know, the PTP is synchronizing at a level of 1 microsecond. And that synchronization works well for our purpose, because other synchronizations that maybe you are familiar with, like the NTP or SNTP, for our application is not acceptable, cannot be used, because the synchronization goes at the level of 1 millisecond, and we need less than that to guarantee the quality of the sample values that are exchanged. So remember also, in terms of synchronization, PTP, 1 microsecond. And in terms of, let's say, of redundancy, HSR or PRP. But HSR, it's recommended if you want to eliminate a new player in the picture, let's say. In that way, you concentrate everything, all the elements from a single and the same vendor, okay? And of course, it's much cheaper, because as you very well know, the Ethernet switches are costly nowadays. Mainly those ones that are intended for process bus are expensive. So honestly, it's more cheap, it's cost effective, and as I told you, just with one vendor involved, right? By the way, another question that sometimes people ask us in the sales department is, can your busbar differential protection operate with bay units from another vendor? Well, unfortunately, the answer is no. We cannot our busbar differential protection cannot operate with bay units from other vendor, because as I mentioned you from the very beginning, well, our algorithms and our solution is based on protection functions that ones are located in the central unit and others are in the bay unit. So the way that everything is interconnected and so on does not permit the use of other bay units from other vendors with our solution. Okay. Another question from Khalid. It needs any additional software to draw the single line diagram? No, you don't need additional software for that. If you refer to for the configuration of the 61850, just by in the same ZIB init tool, you will say which are the busbars, how many, which are the bays, how many couplers of bays, if you have disconnectors for busbar 1 and for busbar 2, etc. And with that, how to say, the topology of your substation will be on the central unit, but you don't need a specific software for that. Well, anyway, this is just a first pill for you to be aware of our busbar differential protection and how it operates under a process bus. Well, maybe I am another question that maybe at the moment you may wonder yourself is related to the couplers. For example, maybe in some of the cases you may have couplers with 2 CTs. Can we work with such kind of couplers? Yes, the answer is yes. In fact, we have been working in substations where the couplers were equipped with 2 CTs, one at each side of the breaker. And for those cases, the only thing to keep in mind is that you should employ 2 bay units, one related to each city, and that's it. So there is no limitation. You may have any kind of coupler that you have, that be sure that we can operate with it, no problem. Well, and at this point, again, thank you very much for your presence today. And again, I encourage you to check this presentation again, because, by the way, now at the end of the session, you will receive an email with the recording of the session. But more than that, I think that my colleagues in the chat will drop a link so that you can download the PDF of my presentation of today. So you may check this for your further information, and feel free to contact us back for any clarification or more discussions in depth or whatever. So thank you very much, and see you next time. Thank you.